Hello students, today we are going to start new chapter, that is chapter 12. The name of the chapter is amine, part 1. Now let's start the basic introductions of amine. Now amine means amine are the organic compounds derived from the ammonia. So from the ammonia we have to derive the amine, that is we just say amine. So now here this amine is, this is the representation form. Now here this amine is an alkyne. So now here R, then single bond, then NH2, that is the amide group, functional group, and then if having only one, then we said primary amine. Then if R2 having, then secondary. If R3 having, then tertiary, that is 3 degree amine. So now here these are the alkyl group only. Now if we are taking the aryl group, that is an aromatic, so likewise here also, here AR, then NH2, then primary, and then if 2, then secondary, like that. If 3, then tertiary, like that. It's now this amine is important, is very important, and then it occurs in the nature. That means what we are taking the food, that also presents only this amine. So that means in the form of protein, vitamin, hormones, like that. So that means it presents in the living lifestyle only. And then in another way it also used in the synthetic way. So that means polymers, drugs, then dyes. Drugs means medicine only. So this amide is also occurs in the synthetic forms, that is in the polymers or in the drugs or in dyes. And then in another ones, these amides, that is also novocaine. So these novocaines, that is the anesthetic drug only. So that anesthetic drugs, these drugs is used in the use in what we say in the tooth only. That means the dentist doctors are using for this novocaine. So in the exam also asking, so if asking novocaine, then this is in the chapters of amine chapter only, not in the chemical, everyday chemical chemistry lab. Now another one, in these chapters it also happens that diazonium salts. So these diazonium salts, that means in aromatic compounds, then aromatic compounds with dyes only. So these are the basic introductions of amide. Then now next is the structures of amine. So now the hybridization. So hybridizations of amines, that is here we just see this is alkyl R, and then here lone pair is there, then another hydrogen, then this also hydrogen. So that means here this hybridization, here BP means bond pair only. Now here one bond pair is there, another one bond pair is there, another one. So that means what, 3 bond pairs are there, and then along with what, 1 lone pair is there. So that means these hybridizations of amine, that is 4 only. So if it is 4, then we just say sp3 hybridized only. So if sp3 hybridized, that means tetrahedral only, and then the degree of the tetrahedral, that is 109 degree 28 minutes only. Now here this is also having, see, primary, secondary, tertiary, like that we already know. So if even in this one primary, in the primary also having 3 bonds, and then in the tertiary also, in the secondary also, and then in the tertiary also 3 bond pairs are there along with lone pair. Now this is the structures of the hybridized amine only. Now here this nitrogen having having 1 lone pair, and then here bond, and this 3 bonds are there. Now this is sp3 hybridized only. Here also sp3 hybridized, but the structure that is not a tetrahedral. The structures of this amine is pyramidal only, and the angle is less than the tetrahedral. So here it is 108 degree 80 degree angles only, this amine. And then this lone pairs, we already know that these lone pairs we are not counted for in the chemical bonding. Now here this, due to the lone pairs, the repulsions of the repulsions of the angle will be decreased only. So if it is decreased, then the angle is 108 degree only. Now if 108 degree, that means what? Pyramidal only. Now the next is the classifications or and nomenclature. So alkyl amine and aryl and aramine. So that the possibility is here 1 degree amine, then 2 degree, then 3 degree. Now only one, that means one hydrogen replaced in ammonia, that is 1 degree. Now example CH3 NH2 is alkyne, 1 degree alkyne. And then if we are taking phenyl, then NH2, then 1 degree aryl. So this is the classification. Now here 2 degree, we will just see 2 degree. So if 2 degree, then means 2 hydrogen replaced from the ammonia. Then here see R, so here only 1 hydrogen is there, so this is 2 degree alkyl. And then here AR 2 times is there, so we just say 2 degree aryl halide, aryl group, aryl amine. Then now here 3 degree, also 3 hydrogens replaced from ammonia, then R 3 times, then alkyl amine or aryl amine. Now here this is the nomenclature. Nomenclature, we have 2 types. One is common name, and then another is IUPAC name. So RNH2, that is an alkyl amine. Then another in the IUPAC name, we will just say alkanamine. Now here we just take an example. Here CH3NH2. So now here's methyl and then NH2. So in common name we just say methyl amine. And then in IUPAC, so here one carbon is there. So 1 carbon, that means met. So then here single bond is there. We just say methanamine. So here the functional group of NH2 is there. So we just say methanamine. Then like that, the next one is also phenyl. Here C6H5, that is aryl amine. Then this aryl amine, that we just say aniline. Then aniline, or in IUP name aniline, then benjanamine, like that. In IUP AC names we just set like that. Now the another one is nomenclature for the 2 degree amine. So 2 degree amine having 2 amine, and amine simple, 2 types are there, simple amine, then mixed amine. So now here the same alkyl group, that is a simple amine, and then different alkyl group, that is mixed amine. Now here the example for simple amine is CH3NH, that means here right side, left side is also CH3, and then right side also CH3, that means both sides are same. So when we give the name, we just say here N methyl. So now here N methyl, in this N methyl is attached, we just say N methyl. Then another methyl is also attached, so N methyl. So we will just say 2 methyls are attached here in this NH group. Then we just say NN dimethyl amine, we will say in common name. So if we say in IUPAC name, then we just say N, then here methyl methanamine. So N-methyl methanamine. Like that we will say, we will give the name in IUPAC. Now another one we just say mix. Mix means different only. Now here CH3 is ethers, then here C2H5 is ethers, then N-alkyne, N-alkyl amine. In IUP name N-alkyl ecanamine. So example N-ethyl, N-methyl amine. Now IUPAC N-methyl ethanamine. We will call it like this. Now here 3 degree nomenclature is CH3 it is in the nitrogen, so this is simple only, and then here 3 methyl group is ethers, so that also in the N. So N 3 times, then trimethylamine. So this is common name. In IUPAC name N dimethyl methanamine. We will give the name in IUPAC. Now next example we just see here C2H5, that is ethyl, and then here in nitrogen ethyl, another ethyl, and then this one is propyl. So we will try to give in common name. So now here in N dimethyl, 2 methyls is there, so 2 ethyl is there, N diethyl, then N propyl amine. So this N amine. Now in IUPAC name we just say NN diethyl propanamine we will give. So here in this the parent chain 1 we have to mention. The next is NH2, then CH2 6 times NH2. So this is in the this is a polymer chapter only, this compound. So now we will give the common name hexa. Hexa means CH2 6 times is there, hexa, then methylene, CH2 methylene, then diamine. So 2 NH2 is there, diamine. So in IUP say hexane 1,6 diamine. Now here another one NH2, then single bond CH2, single bond CH2, double bond CH2. So this group is allyl, means allyl, ALLYL, allyl. So common name allyl amine. In IUPAC prop 2 in 1 amine. So another one is in aniline group, it is bromine. So in which position? Para position. Para position. So now here 2 for bromoaniline, then 2 N for bromoaniline, then N CH2, then N dimethyl aniline, bentanamine. So N toluidine, then 2 amino toluene. So this is the name for the nomenclature. Now next is the preparations of primary amine. Ammonolysis of alkyl halide. Aminolysis of alkyl halide. This is alkyl halide, then ammonia. So this ammonia is behave as a nucleophile only. So this ammonia having 2 lone pair, so that lone pair that will be attached to this R, and then forming the substituted ammonium salt. And then from this compound we have to eliminate a sodium halide and water. So then sodium hydroxide, then primary amine, then alkyl halide, then salt we have to form, and then in this sodium halide, and then water, and then this 2 degree amine, and then after that again we have to take halide, then 3 degree amines. So like that we have to we have to prepare primary, secondary and tertiary from the aminolysis of alkyl halide. Then order of the reactivities of haloalkane. So this is the reactivity series of the haloalkane. Now here alkyl halide, that is alkyl iodide, alkyl bromide, then alkyl chloride. So this is the order of the reactivities of haloalkane. So next is the reductions of nitrile. Reductions of nitrile, here this is the nitrile group only, and then here we will do the reductions. So in that reductions, this when we do reduction, in that time we have to use palladium, platinum, nickel, and then hydrogen. So now that means hydrogenation. So here, if we are using full reductions by using this platinum, palladium, nickel, and then after that what, hydrogenation, and then hydrogenation gas, or we can use sodium amalgam in ethanol. Now if we do reduction in by using this, then in that time we have to get RCH2, then NH2. In that time we again use SNCl, then HCl. So like that we have to get. So in this product, in these products, what we will do now, here this alkyl nitrate, if we are using this stannous chloride and then HCl, in that time we will do partial reduction or partial hydrogenation. This one we already study in Stephan reduction. In that time imine we have to form, and then from this imine we do hydrolysis by using hydronium ion, then we will get this aldehydes. Now the next one is here, in this nitrile we do reduction by using stannous chloride and then HCl, partial hydrogenation, then imine form, and then from these imines we do hydrolyze using water and then forming hydrolyze and then forming this product only. So this is the reductions of the nitrile. Then now next is the reductions of amide. This is the general formula. So amide, then in aluminum hydride, then water, then amine, and then if in this way, see now this is aluminum hydride, so now this is aluminum lithium aluminum hydride. So now aluminum hydride, here one hydrogen is there, and then by forming this we will get lithium aluminum hydride. So this aluminum is in the group 13. Now here the mechanism is there. So here is the compound. Now RC double bond O NH2, then in lithium aluminum hydride we have to use, then here one double bond we have to break and given to here, and then we have to use this lithium aluminum hydride. Here aluminum hydride we have to use, then from this from this aluminum hydride one hydrogen we have to eliminate, and then whatever we have to eliminate, the hydrogen they have to combine to the carbon, because this carbon having less electronegativity, that means it's carry the positive, and then this aluminum will have more electrons that will be connected to this oxygen, and then after that here we will get this compound. From this compound also, here this in lone pair is given to here. When it is given to here, that means it will get double bond is there, and then this one we have to eliminate. So if it is eliminated, then this will be getting only. So now here after that what we will do, this compound, from this compound this double bond we have to eliminate and break and then given to this nitrogen, because this nitrogen is carry positive charge, that means less electron, and then from this OL2 OA aluminum hydride, then from there we have to again attach to this carbon, and then we will get this amine along with lithium oxygen, then aluminum hydrides. Now this is the mechanisms for the what we say reductions of amide. Now next is the reductions of nitro compound. This is nitrobenzene. So in this nitrobenzene also we have to use platinum, palladium, then nickel, then hydrogenation gas, or stannous, and then HCl, then in ethanol as a solvent, then aniline we will get. So this Fe and hydrochloric acid that also can use when we do reductions of nitro compound. So this Fe, iron, and then HCl, that is the best methods for lowering the quantity. Now methyl nitro, then this one we have to use this platinum, palladium, nickel, hydrogenations, then methylamine, then in another one or in ethanol. So in that time we will get primary amine, that is methylamine. Stannous chloride, stannous and then HCl reagents are used very frequently. Now next is continuations for that one. This alkyl nitrile, then palladiums, then hydrogenation, then primary amine. Then next also, if we are using the ketonal carbonyl compounds of amide, then lithium aluminum hydride, then this also we will get. Now next is the Gabriel thalamide synthesis. Now here is the phthalic acid, then in presence of ammonia, then we will get this compound. In this compound again we have to give heat, and then from this compound we have to eliminate amide, then we will get thalliamide. Now thalliamide, from this compound again we do sodium by using sodium hydroxide in alkali solution, or sodium hydroxide or potassium hydroxide in alkyl halide. That if we are using alkyl halide, then that is the main only, we have to do hydrolysis, then we will get what? Primary amine. That means this thalliamide, by using sodium hydroxide or potassium hydroxide, we will get amine product along with the side product, that sol thalliamide. So this is, if we are using this alkyl halide, then the reaction is SN reaction. Now not what primary alkyl amines can do, or aryl amine cannot get the product. Now if we have aryl halide, the partial double bond characteristics is difficult to break the bond. Normally it will not be shown in SN reaction. Now Hofmann bromide degradation. So now here R C double bond O NH2, then bromine, that is the only one unit, and then sodium hydroxide, then we get primary amide, then sodium carbonate, sodium bromide, and along with water. So now here also the same is, if we are using this one, this bromine and some potassium hydroxide degradate, then primary amide. Now not bromine only, one unit used in the mechanism. Now here this mechanism we just see from here, and sodium hydroxide. So hydroxide is given to this hydrogen to form water, Now here, and then this one we have to break, and then forming water. Then after that only this happens. Now again bromine Br2 we have to take. So this Br2 we have to break the bond, and then this Br will have more electron, this one will have less electrons. This one will connect to this nitrogen, and then forming here. So from here nitrogens will be break and then given to here. So when it's given to here, that means this nitrogen will have more electron. Then after that sodium hydroxide. So from sodium hydroxide OH is given to the hydrogen. So if given to the hydrogen, then that will form as a water. Now here again this forming the product R C double bond O, then N Br, like that. So now these nitrogens carry positive negative charge, the negative charge given to here. So when it is given to here, then that will have double bond here, and then this also is eliminated, R is eliminated. So now here given to here, and then again going back, again giving back. So then after that O double bond C triple bond double bond N, then Br. So now again R, which is eliminated from this compound, that one will have to connect it to the nitrogen, and then forming here. Then oxygen hydrolysis, water hydrolysis, water we have to use, that water we have to connect to the oxygen. This double bond we have to break one bond and then given to the nitrogen, then we will get this product. Then from here again we have to eliminate hydrogen, and then forming connected to this product, and then from here again eliminate this carbon dioxide, and then forming primary amine. So this is the mechanism for the Hofmann bromide degradation. So this is the class for today. Thank